Yeah, sorry, good. So here's what we're doing today. We are going to be looking at angles, going to be finding missing angles on triangles, but using the 4 properties we talked about on Friday. So I want to review those properties first, just to make sure, because obviously these are properties, like the first one you knew since Monday, last week. So it's a week ago from today. So we had to use that in some of the problems we did last week. The new properties were Theorem 4.2 and then the 2 corollaries. We're going to be using those today. Now, obviously we had homework that was due last Friday, so if you were gone last week, we had homework due that was, I think it was called Worksheet 4.1. Everything is in Google Classroom. So if you were not here, make sure that you took a look at that and you had that turned in. So those will be in probably tonight, so you'll get to see all your scores on those. So yeah, so I'm going to see if I can modify the grade book to show those, display them correctly. But yeah, today we're going to review. I got about, I don't know, 3 or 4 problems kind of picked from the textbook, the types of problems I'd like you to know. When we're through the 4, we're finished today. We're done. That's all I want to do. I want to complete these 4 problems. You do have a Google question of the day today, so that will go live. So that'll be something you'll get to work on at the end of class. It is technically due tomorrow. Okay, so it's due tomorrow. But you'll probably get it done in here. Once you see these 4 problems I've kind of picked out today, they're pretty straightforward. They're pretty easy. So I want to give you a chance to kind of look them over. All right, questions on what we're doing today. Perfect. Let's jump right in. Let's review these properties. So these were the ones I think we went through on, what, last Thursday, something like that, or even last Wednesday, I think. So, all right, so the first one here, this is the Theorem 4.1. This is one we did last Monday. This is the only one we did on Monday. It was the sum of the interior angles. When you add up all the angles inside a polygon, triangle I should say, it's going to make 180 every single time. No matter what the triangle is, it could be a right triangle, it could be an obtuse, it could be an equilateral, a scalene. Doesn't matter the type. Every angle on the inside should always add to make 180. We're going to have to use that fact. So the idea here, and again, this is just a rough example. If I gave you a triangle, it doesn't matter the type. Okay, if I just give you a triangle and I give you 2 of the angles on the inside. So let's say this angle is 60 degrees and this angle down here is 75 degrees. We can find this missing angle right here. That's kind of the idea of what you're doing for some of your problems, that you're just finding that missing one angle. So the idea is that whatever it is, you can give it any variable you want. You can even leave it a question mark for all I care. But you need to realize from this first theorem that you can add these together and make it equal 180. And then solve for the question mark. Does that make sense what you're doing on those first couple? Okay, we're going to use this a lot today. It's almost going to be used at least in almost every single problem in some form or fashion. So again, if we were to solve this out, you'd subtract the 60 and the 70 across. It doesn't matter. Maybe you want to add these 2 together first to make 135. And then you want to subtract those across. So if we subtract this 135 across, we'll get a 45 degree angle out of that thing, and that's the question mark. That's this angle right here. Again, pictures are not done on a scale, so don't like try to read into it too much. Don't assume anything. Just do your normal math. Whatever it says, just trust it and move on to the next one. So, okay, but that's how you're going to use this first theorem. We're going to see that here. This is not the the 4 problems I picked out of the book. This is just one I kind of made up on the spot. So let's move on to the next theorem. All right, Theorem 4.2, this is one we talked about, the remote interior theorem. That's what your book refers to it as. In other textbooks, it's called the exterior angle theorem. Remember, exterior angles are these angles on the outside. This is an exterior angle. How this works, you have to extend one of the walls. It doesn't matter which wall. You extend one of them further, and this angle, this exterior angle, is always equal to the 2 on the inside that are not touching it. So they're non-adjacent angles. They call them the remote angles, but they're interior. These 2 angles are the remote ones. You add those 2 together, so whatever these 2 add up to be, they're going to equal this one right here every single time. Doesn't matter which 2. So you can pick any 2 angles you want. So how you'd use something like this in your basic problem, how we're going to use it, let's say I give you a triangle, And again, I extend one of the walls further. It doesn't matter which wall I extend. Let's say I extend this wall over here. I go down further that way. Well, then the angle on the outside, let's say that this angle down here is 123 degrees, and this angle up here is a 57 degree angle. And just kind of random numbers thrown at you. We can find this angle right here. In fact, we can find each and every angle of this triangle, but that's what this theorem allows me to do. It allows me to find that one on the inside really, really quickly. Because these two have to add up to make the 123. Okay, does that make sense? Now, again, I said you can find every angle in this triangle because obviously you can find the question mark first, because you could just set this equation up. The question mark plus the 57 can equal the 123. Subtract the 57 across. 123 minus 57, what do we get? 66. And that's that angle, that's 66 degrees. That's this one right here. Now, we can find the other missing angle because now, again, triangles have to add to be 180, and you can find this little piece right here. So, all right, questions on how you could kind of mix the two together now? Okay. All right, let's move on to the next one here. Next, these are the corollaries now. Now these, I don't really use them too often. This one in particular could be useful, in especially chapter 8. You might see out of all the problems, maybe this is used once today, maybe. Acute angles. That's the two angles on the inside. I numbered them 1 and 2. Those are the acute angles on a right triangle. They're the angles that are smaller than 90. They have to be complementary. These two angles have to add up to be 90, whatever they are. The reason why I don't use this too often is because I just use Theorem 4.1 more, where you add up all three and it makes 180. So if I gave you one of these angles, let's say angle 1 was 40 degrees, let's say. So if this was 40 degrees right here, then this angle down here has to be 50, because what this corollary is saying is that these two have to add up to be 90. They're complementary. It equals 90. It adds to 90 degrees. That's what complementary means. So it's really quick if you know one of them. All right, questions with this corollary. And then obviously the last one here, this is the last one you finished. I think this was on Thursday. In any triangle, doesn't matter the type, there can be at most, that means no more than, at most one right angle. So your triangle could be a right triangle, one right angle, or, and that's the word or, this is the big crucial word, they don't stress this word enough, or, if it's obtuse, then you only have one obtuse angle. The other should be acute, no matter what. So it kind of goes off the last one. So, but that was corollary 4.2. So the reason why this is useful, the only reason why is this, it's like a simple check. If you're finding a missing angle in a triangle and you found like it's too big, because you already have one obtuse angle and you found the other, like the missing angle is obtuse, you probably did something wrong. Maybe you added wrong, maybe you typed something in the calculator wrong. One obtuse angle is the maximum you can have in any triangle, or one right angle. So it's one or the other. All right, are we ready to go for these 4 kind of examples today? I really just kind of talked at you right now. Okay, so here's what we're gonna do. We're gonna try this a little bit today. These are not the problems you're gonna be turning in. These are just for your notes. What I'd like you to do is just write these down. So we'll kind of do one at a time, and then you're gonna talk with kind of your neighbors next to you. I don't care which way you turn. Maybe you're gonna talk to one person. I don't know. I'd like you to try to see if you can find the missing angles. What I'm gonna do is I'm gonna call in kind of random people here. To see if you're kind of paying attention, and you can give me one of the angles inside, or whatever your group found it to be, and we'll discuss if it's right or wrong, and how you did it, and all that good stuff. So I need a lot of volunteers today, so don't feel like I'm putting you on the spot. You get some time to work with some neighbors and stuff and figure this stuff out. It should be easy. It's just based on the pictures I've done up to this point. So here's the first one. Now again, I'm mixing a couple triangles together, and you'll see why we're doing this so that I can get multiple questions going here. So here's your first one. It's a little blurry, but all right. The goal here on this question is to find angles 1, 2, and 3. That's what I want you to find. Find the missing angles on this picture. So take 2-3 minutes here with your neighbors, talk it over, draw this problem out in your notes, but I want to find the measures of angle 1, the measure of angle 2, and the measure of angle 3. I want to know what these numbers are, so you're going to need your calculator. So, okay, does that make sense what we're doing? All right, go ahead, try it out. Take a few minutes here. Let's see what you can come up with here. So, angles 1, 2, and 3. Not everyone talk at once. So you're finding the measures, the numbers for them. As big as this gets. I'll give you maybe another minute or so. I don't know if you need a little more time than that. All right, so without me just picking somebody, can I get a brave volunteer that'd like to explain how they found one of the angles? I don't care which one, 2, or 3, doesn't matter. Explain to me how you did it, what number you found, all that good stuff, before I just kind of call on somebody at random. I don't want to put anyone on the spot if I can get a volunteer. Okay, please, Skylar, what do you got?
I got for angle 2, 59.
Okay, so let's talk about it. I agree with you. Angle 2 is a 59. Now let's talk about how did you figure that out? And if there's any disagreements, fire them up there if you got a different number or something like that. All right, so explain, how did you do it?
I subtracted 90 from 31.
Okay, good. According to the last corollary, I should say not the last one, but corollary 4.1, these two angles have to add up to be 90. Okay, it is a right triangle. Those are the acute angles. The acute angles in a right triangle have to be complementary. They have to add up to be 90. I completely agree. And that's why angle 2 is a 59. Okay, so that was good. All right, thank you for that. So somebody else now that we know angle 2 is a 59. In fact, I'm going to mark that on my picture. Let me erase this number and let's put a 59 in that spot. Okay, somebody else now. Hopefully that didn't mess up too many people. What else do we have? I can even ask for the people that are online too, if you guys figured that out. So any others? Please, Jackie, what do you got?
Oh, 1 is 59?
Okay, good. I agree with that. How do you know that angle 1 is also 59?
They're vertical angles.
Yeah, the little funnel system, right? The vertical angles, that's the correct word that you used. The idea is that 59 can transfer the little funnel system, and so it can transfer down to here. So you're absolutely right. Angle 1 is also 59. Okay? And now, angle number 3. So somebody else, thank you for the 2 volunteers. So far you guys are spot on. So, what do we think? Angle number 3, how can we find it? What do you guys think? Brave volunteer. Nope. I need somebody else. Otherwise I'm just going to call on somebody at random. Let's hope we get a volunteer. Bueller. How can we find angle number 3? What do triangles have to add up to be? 180, right? Well, that second triangle, I got 2 of the angles in there. So, how do I find the third one? Please. Yeah, just take 180, subtract the 59, subtract the 22 in that little triangle, and you'll find angle number 3. Thank you. So, again, if we take 180, subtract the 59, subtract the 22, that'll help us find angle number 3, which ends up being a 99-degree angle. So that's this angle down here. So angle number 3 ends up being a 99, which kind of looks like it's almost 90. Again, you don't want to assume that it is. Don't assume anything on these pictures. But yeah, this ends up being a 99-degree angle because of that simple fact. So, all right. Very nice. So that's the style of problems that we're doing today, especially the ones that's on our Google question of the day. So let's try another one of these out. Let's try one where now you're getting in the flow of things here. Let's switch up the picture so it looks a little bit different now. All right. So new one here. Same idea. I'll give you a couple minutes. This might be one of our last problems. I don't know if we'll get to all 4 today. I'll give you a few minutes here to try this one out. You're finding angles 1, 2, and 3 again. Now, before you begin, I want you to note something. I'll erase this little note on this picture here in a second. What do these little pink markers mean? Yeah, angles 1 and 2 have to be the same number, whatever they are. That's what that little marker means. Angle 1 and 2 are going to be the same. That might help you out a little bit. but I'll get rid of that little mark. Okay, give you a few minutes here. Try it out. Work with your neighbor. Talk it over. You guys are too quiet. It's too early for this, I guess. So probably one of our last problems of the day. So I want to give you some time to work on your Google question of the day. And we'll try a couple more of these tomorrow. So that's what our major assignment is going to be like. All right, let's try this out. Let's see what we can do here. Ask for some brave volunteers, maybe some people I haven't talked to yet. You can pick any angle up there. I'm not limiting you to always starting with 1 or 2 or 3. It doesn't matter. If you know how to find one of the angles, throw it out there. What do you find? What was the number? So, do I have a brave volunteer? Nick, what do you got?
I got 3. I got,
Okay, what do you got for angle number 3?
133.
Okay, good. All right, so now explain. How did you do it?
I subtracted 23 and 24 from 180.
Yeah, so you're absolutely right. Where's my little pen at? You're absolutely right. So angle number 3 here, the measure of it. Say it again, what was the number?
133.
There you go. All right, so again, triangles have to add it to be 180, so he knew that these 3 had to add it to be 180, so he took 180, subtracted the other 2, the 23 and the 24, and found 133. I completely agree. That's exactly how I do it too. So, very nice. All right. Somebody else now. Now, these are the tricky ones. Angle 1 and 2. We've already talked about that. The measure of angle 1 has to equal the measure of angle 2. Like, we already know that they have to be the same number. Now, the reason why is because of this little arc symbol. means the angles have to be the same. That's what we discussed in the beginning. So can somebody walk me through how you do it? How can we find it? And I think they turn out to be decimals. So if you got a decimal, trust what your answer is. So I'll take anybody. You can be one of the first people that talk to. All right, Skylar, what do you got?
I got 37.5.
Okay, I agree. They are 37.5. Now let's talk about how did you get that weird number?
I subtracted 105 from 180.
Okay, good. And so that means what's left over, these two angles, because the total triangle has to add up to 180. That angle that when you subtract the 105 has to be what, 75 degrees?
Yeah.
So those two have to make 75, and they're both equal. So then what do you do next?
Divided 75 by 2.
Yep. If you divide 75 by 2, both of them are split perfectly equally. And so if they're both 37.5, they'll add up to be 75, and then they add up with the 105 to make 180. So that's exactly right. So they are both 37.5. Okay. Is there any questions with how that worked? That was good. That's probably the more challenging one. If you want to see the other problems I've kind of picked out, we're not going to go through them, but these are the other ones I had picked out for today. This had a bunch of right angles in it, so you can find them. This particular problem, this 39 could hopscotch to here because of alternate interior. That's probably the only tricky part. Let's see. This one uses remote exterior. So this angle has to be these two added together. So you'd add those two together so they equal to 148 and solve. Then once you find it, then you can plug it back in. So. All right, but that was it for today. All right, your Google question went live, I think about 10 minutes ago. So you can go online, you can go find it. It's in Google Classroom. It's the question of the day today. It's one of these. You're just going to find the missing angle. So when you type in your little answer box, type in, angle 1 is this, angle 2 is this, angle 3 is this. Whatever number of angles. It's meant to be kind of straightforward. There's a lot of numbers in there, so don't be thrown off by that. If you want to see it, I'll pop it up here just so you can see what the question looks like. Let's see if I can pop it up on the board in front of you here. There's only 3 numbers. I thought there was 4, but there's only 3. So, yeah. So here's what it looks like if you're wondering. There you go. So there's your question of the day today. So you're gonna have to find angle 1, 2, and 3. I thought there was a couple more angles on there, but there you go. So submit your answers, find it out. We'll talk about this one tomorrow. Alright, I'm going to stop the recording there. For those who are online, you guys are good to go. So you guys can log off and kind of go work on what you need to.